Hello. In this video, we show several commands to show the descriptive statistics for the bivariate quantitative variables in Python. So we go to Python IDE. So first, we import several modules, Pandas, and import matplotlib pyplot as pyplot. Then we read a data from this link called suicide data, guns and suicide data. This data includes variables for the guns and suicide, and use separate for the space. Correct. Then we show this data frames information. So this is basic information with 51 entries, index 0 to 50, and we have 3 column variables called state, guns, and suicide. So very clear. And guns and suicide are numeric type and state string type. And we can show first several observations for this data frame. So for example, Arkansas, Alabama, California, and so on. Then we can show very basic scatterplot. Just use GS because this is a data frame, so dot plot. So this is from method from Pandas data frame, and with the variable, and with the color and with the size of the figure, then set the label. So this is a sketch plot, very basic for these two quantitative variables. And you can also get the correlation between these two variables. So GS, we use double brackets. So the inside the brackets is like a list for these two variables using quotes, then .corr. So these functions also come from Pandas. So this is the matrix for the correlation between suicide and guns is 0.73. So you can see there are quite positive correlation between these two variables. Then we import NumPy module. Then we can plot a scatter plot with fitted regression line. So first we calculate the coefficient between these two variables. We use a polyfit function from NumPy. Then we use NumPy's poly1D function to calculate the fitted value based on this coefficient. Then we set the figure size and using matplotlib's plot function between these two variables, guns and suicide. Then we set the shape. Then we also plot between guns and fitted values of guns. So using LFN, which defined here, because it included the parameter information, so set GS guns. So then set the label. So this is a quite beautiful figure with the scatter plot between guns and suicide and a fitted line between these two variables. Then we can also formally run linear regression. So import a module from starts module formula API. Then we can use this function sm.ols to ordinary linear regression with the formula between suicide and guns. Then data is gs.fit. Then we can print this regression module's parameter. So intercept is 7.39 and the regression is 0.19. So which means about average unit increase of 1 gun will increase the suicide about 0.19 units. Right? Thanks for watching.